Right, we were closely going through the SD-WAN technologies. We learned about VPN, and we saw there is two VPN reserved, VPN 0 and VPN 512. This VPN 0 is for the transport of controlled VPN, meaning for all those OMP traffic and much more. All the management, all the control traffics, you should say. All the control traffics. VPN 0. And this control traffic, are they end user traffics? Please understand, I'm asking a question. This VPN is 0. This VPN 0. When I say control traffic or transport traffic, are they the traffic running between this subnet to this subnet? Someone answer, yes or no?
No.
Very nice. No.
No.
These are all user traffics. Those control traffics are only between this edge to the another edge, and then edge to the vSmart, vBond, vManage. And the management traffic, VPN 512, is also to communicate to this, all the edge devices only. Difference is that's a telnet traffic. Management traffic is a separate LAN. It's a telnet traffic or SSH traffic to all the devices in the SD-WAN.
That is device-to-device communication, sir, right?
Both are doing device-to-device communication. The only difference is this is the traffic generated by us to log into the device, to configure the device. But this is the device. Sorry, this is the VPN that is between the device as per the vManager's configuration.
Device-to-device communication means I need to say so the management wise.
Yeah. So, two things we have already spoken. Let's see more. I was telling that's a 16-bit reservation. So the service VPN can be between VPN 1 and 65535, in which 0 is already reserved for service or the transport, and 512 is already reserved for management. But that is not the complete story. It shows like 65535 minus this two, how many? 65533 VPNs you can create. No. Yeah, you can create, but if you will have license. You can create multiple VPNs and you can have multiple customers for each VPN. One VPN, one customer. You can create multiple VPNs and you can have multiple tenants to use the SD-WAN, but for which you need to have license. The base license will allow you to have only one tenant. Maybe one hub and spoke you can have, only one hub and spoke. This is hub, these are all spokes. This is called one tenant. Not if you want this full mesh, then multiple VPNs come into picture. If it is only one VPN, it is another VPN. This is another VPN. This is another VPN. If you want to have full mesh or partial mesh, one VPN is not enough. So, when you're planning for more than one VPN, definitely the base license won't support. Another thing is, it's not up to 65535 you can use only up to 65530. That's the last usable VPN number. So 655.3.1.32.3.3.3.4.3.5 is not usable. Though it is there, available, you have 16-bit, though it is available up to 655.3.5, the usable is only up to 655.3.0. Next. This is also a known page for you, but I have added something more. What is OMP? The Overlay Management Protocol that we learned. It's a control plane used to communicate between the controllers like vSmart and vManage and the VH. So the controllers are vSmart, vManage and the V8 or Vantage. See why vBond is not coming here. Yeah, to vBond there is no OMP. Initially, all VHs will go to vBond. After that, they don't communicate anymore to vBond. The tunnel between vBond and V8 will be removed. Only during the beginning stage, initial conversations. Only in the beginning, initial conversation, during the initial conversations, when VH is trying to join this SD-WAN, it knows only vBond. It goes to vBond after authentication. It finds the vManage and vSmart. Once vSmart and vManage is discovered, vBond will no more be in picture. So that's why I'm saying controller as only vManage and vSmart. Fine. So the communication between the vManage, vSmart and the WWAN VH, we use protocol. We see protocol OMP. It's a Cisco proprietary protocol. So what is the responsibility? It is to distribute the route information. Meaning, if you see this picture, all these routes will be coming up to the edge. Likewise, these routes will be in the local edge. Now it is the OMP's job to distribute this to others. So we go to the vManager and we configure the route policy. According to the route policy, the vManager will tell all the vEdges that you may now get ready to distribute. vManager is approving, that's all. vManager just approves the edge device that you may now advertise this. That is the policy. We can advertise to others. The approval is given. vSmart only, as per the vManager's approval, it uses OMP and takes the route and gives to others. This route now is given to others. So now this route is available in the routing table of all these edge device. Likewise, the routes of the other edge device also given to all others. That's the job of OMP. So it is responsible for distributing the reachability information, control policy, like what network can be advertised, via which ISP it has to go, what will be the next hop, what will be the color, what is color, we learned color in the transport locator TLOG. Transport locator TLOG, we learned color. Traffic engineering, that's what color. Which one to choose, which path to choose. So, OMP is responsible for distributing the reachability information according to the control policy and security policy in the WAN. So, all those policies, where did you describe? In vManager. And vManager has pushed those policies to the vEdges. And vSmart knows about every policy. According to the policy, it takes the routes of each edge device and distributes to the others. See, the depth of what I am saying, you will fully understand only when we finish that MPLS layer 3 VPN. It was there in my mind for long days, but since I have started this, thinking that I should give something new, we had a lot of MPLS video in our channel. So that time we started this, I thought, okay, there's video, we'll give some video in the middle and then we'll, but now we don't have that channel, it's stolen already. Now we have to go back, start MPLS. And then come here. Anyhow, we have started this to an extent. I want to go and finish, and then we will go back and learn BGP, we'll learn MPLS, then we'll come back to SD-WAN, and then SD access. Okay. So, this policies and all, you will understand much when we learn that BGP, with BGP only we provide those route policies. In MPLS layer 3 VPN. Anyhow, you will be understanding to an extent. As of now, that's enough. Now, V-edge and C-edges, they form OMP peering with vSmart. That's one of the controller. OMP exchanges three things. Number one, OMP routes, which we just spoke. OMP routes means, the OMP will advertise the routes like, see, this network will be here in the V-edge. Now V-edge is going to distribute this route information to this. Now, what is OMP routes? Policies. Can this V-edge use this route to reach this, or it should use this route to use this? Now, which route it can use? The kind of policies. The service route. How the path can be taken. What are all the routes can be reached, what all network should be advertised, what should not be advertised. All those things are OMP routes. Not all routes are going to be advertised, only those routes that are allowed to advertise as per the policy. And then OMP also exchanges transport locator routes, TLOG. We saw earlier about TLOG. Let's go and see. I have added something more to TLOG now. Okay, let's start from here. What does TLOG provide? It provides the information about the next hop. Next hop based on what? Based on three things. System IP. System IP is a unique identification for each device. It's like a router ID, I told you. It's like a router ID. See? It's like a router ID. System IP is like a router ID. And then, which tunnel to take based on the color. Should I take the MPLS path? Should I take IP path? Should I take another WAN path? And then how should I encapsulate? Should I encapsulate with GRE or IPsec? See, both are encapsulation. GRE is not secured, IPsec is more secured. So recommended and the default is IPsec. All these three is what going to decide the next hop. I want this type of colored path, and the next hop IP address should be this system ID, and I want an IPsec encapsulation. Whichever the path that suits all these three requirements will become the next hop. So this TLOG is made up of these three components: system IP, the tunnel color, and the encapsulation. You see here, I've added something more. One TLOG per WAN circuit. See, every WAN circuit will have one particular color, one particular system ID. And encapsulation all may support IPsec, but the system ID and the color will be one per TLOG, one per circuit, one TLOG per circuit. TLOG is what? TLOG is combination of the above three. That's a kind of policy. I need this color. I need this color means what? I need MPLS path, and I need the system ID should be system IP should need to be this. An encapsulation protocol need to be this. For example, there will be 4 tunnel attempting between 2 routers that have 2 internet. WAN circuits are by default. So, this is just an example. Which I said per circuit, per TLOG. If I have 4 tunnels, then there are 4 TLOGs, one per each. So there are 4 tunnels connection. It is not attempted between, it is attached between 2 routers. That's a mistake. 2 routers that each have 2 internets and 2 WAN circuit by default. So if you have 2 internet, there is going to be 2 internet and 2 WAN circuit, then there is going to be 4 TLOGs, one per each. Let me make it clear for you again. You see, you got 2 internet and 2 WAN circuit. So totally how many tunnels now you can see? You will see 4 tunnels. That's what it means. Because for this 2, there is 2 tunnel. This two tunnel, meaning two transport locator, two tunnels, that's what it means. Two transport locator. Each transport locator will have all these three. So when we say tunnel, it means the path with these three properties: a system ID, a color, and encapsulation. So you will have four paths, that is what it means, four tunnels. Between A and B you will have four tunnels, because between A and B you got two internet and two WAN circuits. So this is what called as WAN circuits, MPLS. This is WAN circuit. This is one WAN circuit, one internet connection. Here you got only two tunnels. In this example you got four tunnels. Right. Now a few more things added now. This is totally new. We have not discussed this in the previous class. Traffic forwarding. Each edge can have up to 7 WAN connections. 7 WAN connections. How many connections we have in this in the picture? How many WAN connections we had in that picture?
Two.
Two. One is real WAN, another one is IP network, internet network. Likewise, you can have 7 connections between the between any two device, any two edges. Now, when you are doing forwarding, traffic forwarding, there are 4 different ways you can do that. Across the 7 links, you can have active load sharing, or active weighted. More weightage, more traffic will go on that. See, this is equally load shared. Active load sharing is all the tunnels are seen equal. All the 7 WAN connections or all the tunnels are seen equal. Weighted means you provide the weightage. This tunnel is more bandwidth, so I want more traffic to go. This tunnel, medium size bandwidth. The other one is low bandwidth. So according to the capacity, you can also load balance. That is what active weighted. Another one, we manually pin it. Applications that wants to use the SD-WAN tunnels, we map it. First application, you always use the first tunnel. If that goes down, then you may use that second tunnel. So we are doing pinning work. For different application, we are mapping different tunnels. Static pinning. Statically, we are pinning the application to the tunnel. These two are what? Dynamic pinning. They dynamically go and take one tunnel. This is static pinning. Next is according to the SLA, service level agreement. According to the policy, one tunnel will be used, the other will become an standby. So you can do the traffic forwarding between the WAN edges using 7 tunnels, and by using any of this as per your expectation, as per your policy. Now, when we say application pinning, how do you identify application? Applications are identified in 2 ways. One, deep packet inspection. The other one, the 6 parameters. So you are writing an access list to identify an application. How do you identify a traffic? Source address, destination address, protocol, port number. Correct? That's how we identify a traffic. So this protocol, the port number, and the IP address, are they within that layer 1, layer 2, layer 3 and layer 4, or they are above layer 4? They're all below layer 4. Port number is layer 4. Port number is layer 4, source and destination port. IP address, source and destination IP address is layer 3. Protocol number is layer 4, layer 3. Layer 3 protocol number. DSCP is a marking that you do in layer 2 and layer 3 level. So none of these are focusing on layer 5 to 7. They are all layer 2 to 4. So if you are going to decide an application, a traffic coming from an application, so that is how you identify an application. We know that application will send this protocol traffic, and it is marked with this differentiated service code point, and it will be going between this source and destination IP and port number. So if you are going to identify a traffic using this, you don't need a license. Base license is enough. But if you want to do deep packet inspection, meaning layer 4 to layer 7 information, if you want to match layer 4 to layer 7 information, for example, I want to match the traffic that has got COVID-19 as a payload. See, someone is writing some email. In that email, if the word COVID-19 is mentioned, this can find out this can identify the traffic. That is deep packet inspection. Looking deep into packet, and it can read what is going inside the packet and match the packet traffic. Can COVID-19 matched in this second one? No. The word COVID-19 is in the top application layer payload. Further deep packet inspection is needed. Layer 7. So every traffic that has got that word COVID-19 will be stopped, will be identified, will be matched. For that you need license, additional license. So you may pin the application to the tunnels for traffic sharing, load sharing across the multiple path, either by using the deep packet inspection or the 6 tuple match. For the 6 tuple match, there is no need for license. For the deep packet inspection, we need license. Do you have any question in this?
So the application aware SLA.
That we write. We only write the service level agreement using any one of this, either by using 6 tuple match or by deep packet inspection. We write a service level agreement. We say if this matches if this address is reachable, do this. If it is not, do that. That is called service level agreement. That is kind of policy. It is same like the above one, the third one, but this, you just take an application and pin it. This is additionally, you keep another check. I want to pin this application if that works, if this works. That condition is what service level agreement. This SLA is a common word. This comes in different meaning in different place. Basically, you got a agreement for the service to be provided. If that is valid, then you do this. That is what agreement. Right. Any other question? Now, one more thing I want to... DSCP is the way that we mark traffic to provide some quality of service. In layer 3, we have 6-bit for DSCP. We use that 6-bit to do different type of marking to differentiate the traffic. DSCP stands for Differentiated Service Code Point. Differentiated Service Code Point. When we go to QoS topic, you will learn this. QoS. In QoS, we will learn this. Differentiated Service Code Point.
Got it. Thank you.
You're welcome. Now you see, we are going to discuss on another small topic called TLS and DTLS. When I say TLS and DTLS, you can just compare this to TCP and UDP. What does TCP stands for? Transmission Control Protocol. TLS stands for Transport Layer Security. The DTLS stands for Datagram Transport Layer Security. Basically, it uses UDP. DTLS uses UDP. What does UDP stands for? User Datagram Protocol. See the datagram, same datagram comes here. Datagram Transport Layer Security. TLS Transport Layer Security. Now, any connection with V-bond, any connection with V-bond is only by using this UDP DTLS. It's a temporary connection actually. All V edges will use this DTLS and form a temporary connection. VH to V-bond. Using DTLS. It's temporary connection. First, every device goes to V-bond, right? So, likewise, V-bond helps the VH to form TLS. So, V-bond only provides the information about vManage and vSmart. Using that information, VH forms connection With whom? vManage
vSmart.
and vSmart. But this time what it will use? It will not use the user datagram stuff. It will use TLS. The transport layer security. So using TLS, the V edges are forming tunnel with V edge and V manage. But for that, initially all the V edges were forming tunnel using DTLS to the V bond. Once it knows the location of V manage and V smart via V bond, V edges can form connection with tunnel with V manage and V smart using the reliable TLS. Once the tunnel is established with V manage and V smart, once the tunnel is established, the V bond V edge tunnel will be removed. V bond and V edge tunnel will not be there forever. Initially it will be there temporarily, that's what I said, temporary DTLS connection. Once the edges discovered the vManage and vSmart and form TLS connection, there is no need for DTLS connection with vBond. That will be removed. Now if you have two WAN connections, then you will have two connections with vManage and vSmart. In our diagrams we have two connections. If you see, for this edge, this is one connection to vSmart and vManage. This is another connection to vSmart and vManage. Sorry, this one. So it will form two connections, two TLS connections. So if we have two WAN, then two connections to vManage and vSmart. Connections to vManage will be active standby. Please pay attention to this. When we have two connections, both will not be active. To vManage, one will be active, one connection will be standby. Whereas connections to tunnels to vSmart, both will be active. Both WAN connection, both the tunnels will be active. Right? So today we have added something more to what we know earlier. We learned now these two protocols that runs between the controllers and the V edges, the DTLS, the datagram transport layer security, and the transport layer security. And also, yes.
Can you say just a little bit more deep into the TLS? Because I just wanted to know. We always face problem TLS.
That's again another layer 4 protocol. It is just like a
I'm not talking about the vSmarts in that standpoint. The TLS basically how it works. Basically what exactly the use of.
So we learned about the VPNs, and again we saw the usable VPN is 65530. For multi-tenant you need license. Only one VPN you can make with a base license. And also we learned about the OMP exchanges using the OMP route, service chaining. Okay, about the service chaining we have not seen. Service chaining is like, see, one V edge is talking to another V edge, one V edge is talking to another V edge, but in between it goes to a chain of reaction, like it goes to a firewall, it goes to a IPS for inspection, and then only it goes to the other edge. That is what the service chain. So all this thing, is distributed, advertised using OMP. To verify, these are the commands that we will use. Show OMP peers on the command line if you want to verify. Show OMP peers, show via OMP route, show OMP TLOGs, transport locator, to show via OMP service for service chaining. And also we learned about the T locators, transport locator. We also learned that there can be 7 WAN connections maximum, and you can have load sharing in this 4 different ways. Yep.